Here we are on part 3 of the accumulation function fundamental theorem of calculus. We ended the last time by saying that if you have the integral from 0 to x of f of t dt, and if you take the derivative with respect to x of that, the answer is just f of x. So in effect, it's overly simplistic, but in effect, we're just saying that the derivative and the integral will cancel each other out. In other words, start with a function, you go up to the big F, if you will, and then we derive that. It'll take us right back down to the little f, but it's evaluated at x by the fundamental theorem of calculus. So let g be the function given by g of x is equal to the integral from 2 to x of f of t dt. So g is going to be the area from positive 2 to any value of x that we're looking at, which in this case is going to be 5. G prime of 5 by the result above is just going to equal f of 5. So we'll get to that in just a second. And then g double prime would just be the derivative of f evaluated at 5, or the slope of the function. So we'll do that in a second, but let's start with g of 5. So that is the integral from 2 to 5 of f of t dt. So we are integrating from 2 to 5. So that's just a triangle, so it's 1/2 times the base, which is 3, and the height is 3. So I get 9/2, or 4.5. G prime of 5, as stated above, is the same as f of 5, which is 0. And g double prime of 5 will be the derivative of f evaluated at 5. So the slope here, well, this is linear, so we can go y2 minus y1, which is 6. x2 minus x1 is -6. So we get g double prime of 5 is -1. Right. Let's move on to the next one. We're going to find g of 0. To do this, I'm going to go ahead and just erase what I have up here on this graph. So g of 0 is the integral from 2 to 0 of f of t dt. So we're going from 2 to 0. Now again, because we are going to the left from 2 to 0, this is going to be negative. We could switch the bounds, but we don't need to. And again, this is a trapezoid, so it's going to be 1/2. The height of the trapezoid is 2, and the bases are 3 and 1. So half of 2 is 1, 3 plus 1 is 4, so we get -4 for g of 0. G prime of 0 will be, just like we did up here above, it's the same as f of 0, and f of 0 is 1. And g double prime of 0 is the same as f prime of 0. And because we have a corner here, we can know that the derivative does not exist. The other way is that the limit from the left, the slope is going to be negative, and coming from the right, it's going to be positive. Again, it doesn't exist. So if you want, you can just say we have a corner at x equals 0. All right, that's the next example. So we'll go on and we'll do the function h of x in the next recording.